Hello, everyone. This time, at least for me, it's good morning. How is everyone doing? I figured out some time this morning, so I'm gonna see if somebody's gonna even bother watching it this time. Apparently, according to Google and YouTube, not a lot of people are watching on Saturday. Everyone is watching at least my content on Sunday. But oh well, we have some nimming to do. We're gonna continue with where we left off last night, which is, we're working on CBOR protocol for SurrealDB. And when we finished is basically we implemented the basic unsigned integer and negative integer. So I should actually have it positive, negative integer, right? Because these are the types represented in CBOR. And we can move on to number 2, which is warning, bright light. Major type 2, right? Let me just double check. Yeah. Which is a byte string. The number of bytes in a string is equal to the argument. For example, a byte string whose length is 5. Whose? What? Hello, Taras. Taras is asking if I have slept. Yes, I have slept. Good old, what is it, 7 hours or something? Yeah. Byte string, have you slept? Whose length is 5 would have an initial byte of, 2 and 5, followed by 5 bytes of binary content. That's great, but I just remembered that I was asking around, and we actually could have optimization for our integers, how we're loading them from the bytes, from the byte array. So I wanted to try it out because I'm really, really, really curious. So if I'm going to our types values integer value, it's actually not here. It's in our decoder or reader, right? That says I want to sleep. You were streaming. I woke up and you're streaming. I guess you had a good long sleep. I literally just ate breakfast and figured out, you know what? I have maybe an hour or two, so why not? While I'm in CBOR mode. So in our reader, we have the read uint 8, read uint 16, and they basically load data from bytes, right? And I wonder if instead I could do something like result, because it's uint 16 is, and this is the fun part. What was it? Copy mem, and we copy it to the result, right? Because that's our destination, and source is reader data, the reader position, and we want 2 bytes. So in theory, we could replace all this with that. In theory. But the thing is, I am not sure if the endians, little endian, big endian, whatever, is actually compatible together with CBOR. So I'm curious. Let's search for endian. Terminology. Term byte is used in its now customary sense as a synonym for octet. All multi-byte values are encoded in network byte order. That is most significant byte first, also known as big endian. Okay, so we've got big endian. That's great. Now what about nim? Nemlang.org. Let's go to documentation. And let's see if we can find something about it in the language manual. Gonna search for endian. No mention of that. And I was asking, do you have any tests yet? Absolutely not. I don't have any tests yet because I don't. Since you went to sleep, I did very little. I finished shortly after, but besides our, what do you remember, reading the integers and whatnot, the whole head thing, we went over to the decode where we got the head, and depending on the major, we have our things to cover, right? And what I'm doing here is basically, okay, if it's 0, that means positive integer, so we have reader get full argument. That gives us the uint 64 as the number that we read, and then I'm just making it to a surreal int. So that's the thing that implement the surreal value. So the thing is that this decode, it needs to return some kind of shared type of value, like one type of value that could hold integers, could hold string bytes, whatever, byte strings, could hold objects, or hold, megabytes of variously formatted data. So we need a way to represent it. So I made a surreal types, which is basically an enum that right now we have surreal integer in. We'll be adding more because the next thing will be surreal bytes, okay, because surreal supports bytes type. So that's that. And then we have surreal value. So this is basically a typed union. I think that's the name for it. And right now we have only one type, one kind of it, which is the surreal integer. Now I'll be adding of surreal bytes, and that will basically hold a sequence of bytes, right? And those type unions, they work in a way that the size of the whole object is the largest possible held depending on the type. Okay, so they kind of share the memory for all the various types, and they try to stay optimal, and that's great. And what it means is that we can put all those types of data inside one object as one type, and then discriminate over the discriminator, which in them is kind. And then for the specific integer value, I basically made a bunch of really dumb converters where we can just grab some kind of uint and convert it to that surreal value. The same thing by grabbing negative int, forcing it. Normal integers where it figures out if it's negative or not, because remember, CBOR takes uint64 and has two different tabs depending of positive or negative, so it can theoretically store values in much larger space. And then what? Just a few operators and then conversions from the surreal value to integers depending on what you want. So a bunch of dumb code with a bunch of checks. But this allows us in the decoder to just say, hey, let's take that integer that we got and turn it into surreal int, or to surreal negative int, and so on. So that's what I did, Taras. That's what I did so far, and not a lot. And Twitch is already busy with bots. So let's do /ban. There we go. Banning is boring. Okay. So the whole idea is now we can move on to implementing that byte string. So we know that, but like I mentioned, I wanted to just make sure or find a way to make these a little bit faster and more concise. And I don't really have a specific way of testing it because I would need to capture some CBOR from SurrealDB with some numbers or whatever to actually be able to test data, I guess. I'm not sure. So I want to know basically if NIM language is big endian, stores data as big endian or low endian. And this way I would know if I can just copy whatever bytes were sent from CBOR. And that hopefully would mean that makes sense. I'm not sure. So that's what I wanted to check somehow. But I'm not sure that it makes sense. Because big endian, lower endian, isn't that kind of based on your operating system? I have no clue, to be honest. Uh, let's ask AI, because that's some... Oh, wow, okay. We can ask AI. Oh, well. Gonna ask a different AI. Are programming languages... That doesn't make sense that it would do, because it based on C. Huh. What decides if integers in memory are stored as big endian or low endian? Is it system, programming language, or something else? Like, a CPU or something. I have no idea. Processor CPU. Okay. Uh-huh. Integers, range, memory, for example. These use little... Oh, little. Jesus, I'm saying low endian. Little endian. Oh. Yeah, I could have asked Google, but I want some more context. Google will give me just a bunch of random stuff. Okay, that makes sense. And the programming language itself doesn't decide endiness. It follows the system's architecture. Okay, so very likely I have little endian, so I can't just copy the memory. I just need to specifically load them. Huh. Okay. So let me go to Discord and see what Beef wrote to me, because he had some decent examples at some point. Where could it be? You can probably do big endian result address data from standard endian. Okay, sure. So what was recommended is to do this. So I would need to get endians. That's the package. And we could use, in theory, the big endian. So let's look at its documentation. And in manual standard library, and we'll have endians. There we go. Already run search for that, right? So this should be 16. Big endian 16. Copies the input pointer to output pointer, storing it in 16-bit big endian order. Both buffers are supposed to contain at least 2 bytes. Okay. Storing is the big endian order. Okay, I'm getting confused. So if I want to work as integer, which is system dependent, so this suggests that it's storing as a 16-bit endian. But I want to figure out which one to from, because I can swap them, and that's it. What the heck? Endianness is the order of bytes in value of memory. Big endian means that the most and we unstable API, yay. I'm so confused. So we know that we get bytes from CBOR as what is it? As big endian. Yeah, and big endian means the most significant byte is stored at the smallest memory address. So yeah, so the largest, the first bit is the one that changes the most. Yeah, so that's what we were looking at so far. But how do I put it? Hey, copy it into my system format so that I can use it as a normal integer. What the heck? Do I need to actually? I think I will actually need to test it and see if I can get some results. But of course, we won't write it as an actual test because that would be too easy. What we're gonna do is gonna hack it and just do Control A, just comment it out. What we're gonna do is say, so we can start with this big endian 16. Okay, so this will be 2 bytes. So yeah, let's try that. We're gonna say that we have constant byte 1 is, and in binary we're gonna say that it's all zeros, okay? And then byte 2 is just 1. So it should be, if we would read it as big endian from left to right, that would mean that it's that it's just a value of 1. While for little endian, it would be a very large value. Don't even know what kind of value, probably 65,000 or something. So we're gonna put it in a sequence and try to read it with this big endian, and we'll do it right after I'm back. Just a short bathroom break. Be right back. All right, I'm back. So let's do let bytes, and we just have a sequence of those 2 bytes, right? That's what we want. So now let's do echo bytes. Yeah, sure. Let's see what happens if we're gonna run it. Got 0 and 1. There we go. Because this is supposed to be 0 and this is supposed to be 1. And it figured that out. So if I'm gonna do this, the other value will be something else, right? 200 something, 129. Huh. So this suggests that we already are in a good endian. If that's being understood as that, what the heck? So what if I'm gonna do something like let you know uh, value is, and we're gonna try our first approach, okay? We are going to try our first approach. So where were we doing that? In a reader. This was our first approach to try to use that. And we're just gonna call it bytes, and we do 0 and we do 1. Okay? So this is our initial approach. And echo value. And I just want to specify that I want it to be NU and 16, just so we're double sure. I'm gonna run this task. It's gonna be, oh, sorry, we don't have bit and. I can just probably plop it here, right? Import bit ops and endians for the future. Sure. It already shows that I'm using endians. What? Where? I'm not using them. Okay. So it shows that it's 0. What the heck? Do I need to specify that this is U8 as a byte so that they get understood properly? No. So this isn't working because it ignores my value. Huh. What if I'm gonna put another one here? Because maybe it's something with sign or whatever? No. This 100% doesn't work. So what if I did it the old way? Or how about that? That worked. Okay. Old way worked. So let's call the value 1. And let's do let value 2, which is again U and 16. Okay. And then we're gonna do big endian, right? We want to plop it into the value here. And we start here. So let me just double make sure. Big endian. Output and input. And these are just pointers. So we get pointers to them. And then echo value 2. What is this gonna do? Let symbol requires an initialization. Sure, there goes 0. Legal storage access. Because we need to make it a var. Okay, so that converted it to the same thing. What if I'm gonna make it little endian? Is it gonna be switching it around? Yeah, okay, so that switched it. So it suggests that big endian is the way I'm already doing things. Me confused. Me very confused. How do I detect it? endianness of the system. That's another thing. How on earth do I do that? Let's see if we search for endian. So we got stuff from endians. And then we have system CPU endian. That might be it. It returns the endianness of the thing. Okay, I am getting real confused. So CPU endian. Sure. Echo CPU endian. Okay, what are we going to get? Little endian. Okay, so apparently our CPU is little endian. And when we're reading those values, they must... What? Oh, because we wrote them as big endian. So when we call this, it's happy. But if I'm gonna switch them around, because I'm gonna this one, this will be 2. Wait, no, let's just make it the same way. I'm just gonna say that this is 1, 1, and this is 0, 0. Gosh, no, because it's probably, oh dear God. Taras Mazeppa says, as far as my experience goes, you only get little endian in embedded systems. Why is my... Was it reporting that I have little endian? What the heck? And it shows as a default. This value is a piece of for low-level code only. This works thanks to compiler magic. I really like that. This works thanks to compiler magic. Yep. And wasn't also ChatGPT saying that the CPUs, like x64 and everything, they use little endian. ARM processors can be either, but many modern ARM systems use little endian. What hardware systems, what common hardware systems use big endian? Dominant consumer system, IBM mainframe, PowerPC. Oh wow, old stuff. Spark architecture, Sun Microsystems, so it's old. Network equipment, yeah, big endian is commonly used in networking hardware. Most network protocols, TCP/IP, use big endian, often referred to as network byte order. As a result, many network processors used in router switches handle data in big endian format. Huh. Interesting. So, yeah, that's the thing that I'm confused about. Because this is supposed to be big endian, right? Yeah, we have zeros as this. I mean, 1, 2, 4, 8, and we go from end to front, right? I need to make sure. Examples of big endian and little endian. Do we have any examples? Little endian is basically reversing the byte order for multi-byte value. The 2-byte value where this is the first byte and this is the second byte. Yeah. In little endian, the second byte, or at least 7 different byte, is read in first. So the final representation is this and then that. Oh, but the numbers don't change? What the heck? So I think we have a separation between how we're writing those numbers. These are always written in a big endian format. We just switch bytes. So if I'm gonna make it big endian 16, because that's what I wrote it as, byte 1 and 2, it's gonna get converted to whatever my systems thing is, I guess. Run it. Okay, we've got 3. If I will want to have 3 in little endian, I would just swap those. Somehow the representation will stay, right? So now I'm gonna say it's little endian. And will that just magically work? Yeah, that just worked. So the representation of bytes stayed the same. And this is basically load the memory that's in that specific format and convert it to mine. I want to see implementation of little and big endian. How the hell does it work behind the scenes? So we're going deep. We're figuring out how system stuff works. This is new ground for me. So let's go to source of this thing. Big endian. Swap endian 16. What? When define this, this, and that, use build and swap. Okay, so why does it do swap? Okay, so if it's little endian, it just straight up does copy memory. Okay. While if we're going big endian, it just swaps it. Huh. That's all that's happening here. So that suggests that what nim is always running as little endian, and that's it. So it suggests that it's always storing the stuff. Because when we have this GCC and other stuff, just use the built-in swaps, right? And all the stuff. Use build and swap. It does implement its own stuff. And that's it. And we just change the order of bytes, and that's it. Huh. That's different. Didn't expect that. So I just say that, hey, load the big endian and just call it a day. Okay, I can live with that. Because I know that what I received was a big endian, so the rest should figure itself out. Okay, I don't mind that. I 100% don't mind that. So let's grab all this. Okay, we revert, revert back to normal. And we're going to our reader. And we can just say, load the big endian from this address, from data. And that's it. It's just gonna copy the memory and swap it. So no need for any bit operations or anything else, just one line. And that means we can just replace this whole thing with that as well. Just instead of 16, it's gonna be 32. And here's gonna be 64. There we go. That simplified a few things. And with a single byte, there's no point of this big endian because representation will be always the same. Okay. All right. We're good. So at least now we know that it should more likely work. And I guess we should make this tests for the read head and all that stuff. So maybe we're gonna do that. I'm gonna try to make you happy, Taras. Oh no. Oh no. Let me just answer something quickly. Some questions. So testing. I believe Nimble already has some way to, like, built-in way to test, right? Nimble manual or something like that. Nimble nim manual. Nimble user guide. I think that's the thing. Yeah, okay. Taz says tests make me feel safe and grounded. Yeah, there is something about it. For longest time in Nim, I'm kind of avoiding testing and other things because it seems very weird and tedious. So we've got that. Install Nimble, use existing packages, create packages, Nimble develop workflow. So we have a Nimble setup. Command creates Nimble paths, file containing file system paths with dependencies. It also includes the paths and the config nims. What is going on with my internet? Is it going down again? Okay, maybe not. It's just YouTube complaining. Okay, we've got Nimble lock and all that fun stuff. Develop. And we had also Nimble test somewhere. Nimble link, whatever that is. Sync. We'll synchronize develop mode dependencies with the content of the log file. Okay. And that's it. Really? Miscellaneous? Others banner packages. How the hell did I have testing set up at that point? Nimble test. There we go. Nimble offers predefined test task that compiles and runs all files in the tests directory beginning with letter T in their file name. Name flags provided to Nimble test will be forwarded to the compiler when building the tests. If we run Nimble test in our example project created section above, okay, so Nimble test and we'll just run all of them, right? You may wish to override the default test task with your .nimble file. Here is a real-world example of a custom test task which runs tests from 7 different test files. Test for file and blah 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 blah. Run it. Okay, but we can just use the built-in one. So we just need the test directory and grab stuff there. Okay. And what is going on? Yeah, YouTube is struggling for no reason. Sorry about that. So, and here we are going to, besides source directory, we're gonna create a new directory called test or tests. In the tests directory, right? Yeah, tests. So we're gonna create a new file and call it test underscore CBOR underscore head. Okay, we're gonna try that first. So this will be inside our reader. So maybe not head, let's just call it CBOR reader, okay? Because we're gonna shove all those tests here. And I don't know if it goes into subfolders or whatnot. For now, we're just gonna do that. So I will need to import this reader class, right? So we're gonna do import. And now is the fun part. We go up, then source, then surreal, then we go private, then we go CBOR, and then we go grab our reader. Oof. So in that case, oh, and we also need the types, right? Because the read head returns head major and head argument. So types. So it just runs the code, right? Great. So let me actually look at some other project that I made before where I had a little bit of tests. So instead of going here, I'm gonna go here, my repositories, and we can search for common FS. I think I had it here. Initially where I was starting to learn NIM 4 months ago. Look at that. We have tests, right? Inside tests, we have something like, for example, test current directory. So I imported stuff, imported common FS because I had it set up a little bit differently. Okay, and I'm using this unit test to get common FS, suite, and all that stuff. So let's do that. We're gonna start with that. I kind of like that so far we didn't need to install a single external package to do all this fun stuff for SurrealDB. Like, we're gonna go to Nimble. The only thing we installed is just WebSockets. And other than that, nothing. So I'm liking that. It's totally unlike JavaScript. Or Python. So we define a suite where we can define some variables. And we can have our setup. And then a bunch of tests. Okay? Okay. That sounds good. And do we have something after that to destroy stuff? No, we don't. Okay. That sounds like a good template. So our first test will be CBOR reader. I don't know if we need that. Maybe. What the heck? This is current directory, and the other suite is get absolute path to. Okay, I guess I need to do some of those. I don't think we need any variables right now. I don't think we even need setup right now. So let's do head should return correct major. Okay, we're just gonna check major first. So first of all, please format it correctly. There we go. So we're gonna do constant data1 is, and we're just gonna say that it's oh, we need to put it inside a sequence. Okay. So let's use an example from, it's sure. Let's use the example. Or not. So we would have for the first thing, and then for the value that should be an integer, and we do 0, 0, 0, 0, 1. Okay, and this should be our number 1. And argument. Okay, I'm just gonna do that. So we're gonna make let reader is new CBOR reader. We just give it the data. Hey, we can actually just straight up do this. Okay, this way we can keep building that up in ways that we actually need it. Okay? Because some other parameters will just run a little bit longer. Okay. So if we've got that, we can basically say let major an argument is read head. Okay? And then we're gonna do the check that major is 0 and check that argument is 1. Okay? And then on top of that, I want to do let full argument, get full argument. There we go. And we still need to check if it's just 1. There we go. So that will be our first test. And I want to see if I'm gonna do nimble. Whoa. Nimble test. Will that run it? Unidentified, undeclared identifier data. Where? Reader. 20, 22, 20, what, 23? 30. Oh, of course. Tara says, can I propose a name for a CBOR NIM library? You can, although this library is straight up embedded into the surreal.nim. So, because the whole idea of the because there are some libraries that are specifically for CBOR, for already made for NIM. It's just they are very generic and very large to support everything that CBOR provides. And here we're focusing on A, just learning something by recreating the protocol, and B, making it specifically optimized for SurrealDB. And by optimized, what is going on? YouTube is struggling. See burrito. That's a good one. What's going on with YouTube? Am I like breaking up or something? What the heck? Twitch is fine. YouTube is struggling. Don't know. For me, it's just forever loading. What the heck's going on? Let me disconnect YouTube and I'm gonna reconnect. So I'll be right back. So maybe, just maybe, this is gonna be fixed. But at the same time, I have no clue if that's the case. So please let me know. Okay, so what we're doing here? Yeah, not data. Everywhere I have data. Read.position. What the hell is read? So reader dot data and reader dot position. That should fix it. I hope. It's weird. We're not getting error highlights or anything else. So something broke. And Tara says I use YouTube on phone and TV and Twitch on laptop. Okay. I use YouTube everywhere. Twitch nowhere. I like literally never go on Twitch. Okay, let's try to see if that works now. Ooh ha! Expected type but got 0. Constance nim. What? Where am I using this? I'm not using that type. I don't need this file anymore in the first place. Where the hell am I importing that? instance, delete. There we go. I don't know what is trying to use this file. Whoops. Wrong thing. Can I open file? Shared imports. No, this is in surreal.nim. Oh, because I was using it here just for the thingy, and I'm running the wrong task. So you go away because you don't need to be here, and I need to do nimble test. Okay, success. All tests passed. So that means that this worked. So now we just need to run another test. I'm just gonna do number 1, number 2, number 3 for now. Okay, just to have that. So we can get rid of this whole const data 1. That's pointless. We just have our reader. So in our reader, I'm gonna do 1, and this should be our negative number. And I'm gonna say that it's what this will be 1, 2, 4, 8, 9. Okay, so this should be the value 9. So major should be 1, argument should be 9, and here should be still 9. Okay, so that was number 2, and now we're gonna do number 3. So we're gonna go and make it, for example, 101, which will be 1, 2, wait. 1, 2, 4. So it'll be 5. So we know that this should be 5 because they're bytes, and we're gonna make it to be 25 here. Oh geez. How the hell do I make it 25? So this is 16. Okay. If I'm gonna do 25 minus 16, oh dear, 9. So we go like this. 16 plus 8. 24 plus 1 was 25. Okay, so this should be 25. Therefore, I need to add an additional value. 2 numbers, actually, to specify some kind of number. And this would be 0. So let's make a number like 500, okay? So this whole thing here is 256. 512. Wait, no, this is 120. Oh, all the... So this is 128. This will be 256. Okay, 256. Wait, we have the Windows calculator, right? Can we do programmer? I want the number 500. Oh, there we go. It's teeny tiny, but 1, then we have 4 ones and 1 here. So will be 1, 1, 1, 1, 1. Apparently. And this should give us the number 500 here. Let's see if that actually works. If that works, that means we have reading the full argument as well, which would be like super cool. So maybe in tasks, we're gonna add tasks for nimble test. Okay. So label nim run tests. Command nimble test. Sure, whatever. Release mode and whatnot. We do not want that. Verbosity 0? Sure. Or not. We don't want that either. Current working there. Type shell group kind test. This default true for tests. This should be default. Really? Gonna be like that? And this group, this goes here. And we don't have the main one. Oh, there's no main one. What a weird formatting. What the heck? Ew. Save, and we can do... Oh, we don't have the task. Test? About indentation. Oh no. Test CBOR reader. 31. Oh. Yeah. Indentation, this needs to be here. There we go. So Ctrl Shift B is to run the build task. What is the test shortcut I want to learn? Test. Debug all test. Fresh test. Run all tests. Control this and A. What the heck? Okay, this is a little bit more complicated. So I guess I'm just gonna stick to Control Shift P. Expected this, but got this. Oh, because I forgot about existence of commas. Of course I did. Oh, all of them worked. Okay, cool. As we have some tests that are actually not failing. So, big progress. So, I'd consider this to be somewhat tested, the read head, and get full argument. Because we're able to go 25, and the rest is just, we don't need that coverage right now. So that's good. And the rest, I'm assuming it's gonna be exceptions, so I don't care right now. So we need to figure out how to read the uint 8 and uint 16 and all the other stuff. And are we doing that somewhere? Yeah, we're already using those. Okay, so screw that. It worked. Okay, great. So all those are tested with one test. And then let's just check is break. Test is break. Should return true. Should return true for break. Okay. So we just do 1 1 1 1, just a bunch of ones, right? There we go. And is break. Check if it's true. And then we're gonna do another test, which will be saying that it should be false. Return false or not break. I know it's stupid naming. I don't feel inspired for writing tests right now. Let's just shove in a 0 here and maybe a 0 here or something. Yeah. I mean, the thing that the break, yeah, it just needs to be that specific thing. Okay. Huh? What? Whoa. Why is it jumping here? What the heck? Oh, control tab? No. Weird things are happening. So I need to do this first. I need to get that and is break, and I just give it the head. Okay. Check if the head is break. There we go. And should say false. So let's run those tests and make sure that this is actually happening. Yes, it is happening. Great. So those things are done. Is break is tested, get full argument is tested, all of it is tested. Great. So in decoder, we can basically assume that all this is correct. The get negative and whatnot, yeah, in theory, something could go wrong there. But I'll assume it's good now. I want to get finally to byte strings. So in our heck. In our types, surreal types, we added the surreal bytes. So we can go to surreal value, and surreal bytes will just be a sequence of bytes. And that's that. And I'm gonna make it uint 8 because that's more fun. There we go. And this should be just a fat pointer to basically a array in memory, and that's it. Okay. So no big deal. It'll be very little store, probably roughly the same as this. Possibly. Okay. Because this is what? 8 bytes plus, in theory, just 1 byte. In theory, but it might be more. So let's assume that this whole thing is 16 bytes. And this is way less than that because it's just, what? 64-bit pointer, so it's this. And yeah, we have a little bit more. So we have basically the length, which I don't know what size the length is. You know, how many bytes in a sequence, and or fields in a sequence. And then we've got also what is the reserved length or something like that, capacity, something of that sort. And that should be it. So yeah, they should all fit within the same frame. So now in the coder, when we get number 2, this will be the byte string. So let's just see how the byte string is defined in the bright light warning. In here, it was down here somewhere, major type 2, a byte string. The number of bytes in the string is equal to the argument. Okay, for example, a byte string whose length is 5 would have an initial byte, followed by 5 bytes of binary content. A byte string whose length is 500 would have initial 3 bytes. This major type, additional information 2 byte length, followed by the 2 bytes that represent the number 500, and then followed by 500 bytes of binary content. Okay, that makes sense. Great. So what we can basically do is that we've got the head. Let's get the full argument. In this case, it will be number of bytes. Okay. And here, instead of full argument, it's actually value, you know? Because let's just keep things what they are, not just generic, oh, an argument, what does it mean? It's an actual value. Number of bytes. And then we basically need to load that many bytes. So now we need a function to read many bytes. Okay. Let me think. Yeah, so let's say that sequence of bytes is this. Okay. Oh, I guess it should be that, right? This could, in theory, work. I hope. So now I would like to do something like reader. Uh, read bytes. We pass it the pointer to bytes and the number of bytes to read. Okay, this way we can just do copy memory, or maybe don't. Oh, let's just return that array. Let's just return the bytes. So let's say that it will be just straight up just, hey, reader, read bytes, however many, and then we can just, because we're not even adding anything, this is just that. So bytes to serial bytes, and that's it. This will be our code. So we need to implement read bytes because we don't have that. So let's go to our reader again, because we have all that. So let's do proc read bytes. Gross reader, number of bytes, which could be some kind of large number if necessary, and then basically a sequence of year and date. Here's a split number of bytes from CBOR data into a new sequence. So result is new sequence, number of bytes. Okay. Oh, new sequence, and we can say what is the length. So because I know there's new sequence and there's new sequence of capacity. If I will do new sequence like this, it will initialize all the bytes as zeros. But I would want to skip the initialization because then I'm just gonna copy them from one place to another. So I don't think it's that necessary. Unless, can I just return result is reader dot data. I think this is a slice instead of thing, the actual thing. To sequence. I think I could do something like this in theory. Because what this does, it creates a slice, which is not even copying in the data, it's just specifying, pointing at an existing sequence. And then I can turn it into a separate sequence so that I don't have any weird issues. Because the thing is that I'm not 100% sure how that really works. As in, if I have this sequence and then I'll be modifying the reader, I mean, I won't be modifying the reader data, that's the thing. But doesn't mean that the slice is gonna get invalidated, or is the slice going to actually keep the whole array of bytes, existing even after I'm finished with it, just because I'm holding some kind of sequence somewhere? So no, we're just gonna copy that data. Just to be safe. Hmm. Yeah, I want to test that as well. Test. Um, Decode. Ah. So here we're already testing decoding of some integers and whatnot. kind of. But I'm just gonna do test decode positive integer. Okay. That'll be number 1. And I'm just gonna discard it. And we're gonna have test decode negative integer. And then I'm gonna have byte string. Okay. That's what we want to test. So let's say that our reader, or let's say our data, can make it constant, right? And our sequence here will be. So we need to make sure that this is actually number 2. So that actually is. And let's say we have 2 bytes in there. Okay. So this should signify that this is the type 2, which is a byte array. And we have 2 bytes. And we're just gonna do 0, 1, 0, 1. Okay. 1, 0, 1, 0. And the other one will be the reverse. There we go. So now the reader is here. Now, actually, I want to call the code. So let decoded is the code, and we just give it data. There we go. Because the code should take, it takes a CBOR reader or an open array of data. So that's what we're gonna do. Just decode my data. Bam, there we go. So check that it decoded to be serial kind of serial bytes, and check decoded bytes value is 0 is data 1. Okay. And here 1 will be 2. This should be enough of a check. Yeah. Okay, let's run the tests. Error, undeclared, undefined. Oh, the code. Decoder. There we go. Attempting to call undeclared routine to serial bytes. Oh, because of course we don't have that yet. So in our serial types, value, we have this thing, right? So we need to go to values and create a new file, which will be bytes value.nym, where we can form similar kind of mess that we did in the other place. Am I still streaming, or what's going on? Yeah, it looks like I'm streaming. Okay, so that's good. Just got worried for a second because everyone suddenly disappeared. Okay, so what's next? So you can see that this goes away. We want this. Okay, so we had basically 2 serial integer and all this stuff. Serializing, deserializing, all the fun stuff. So with integer, we basically needed to do a lot because we have, so many different types of integers. So we had the 2 serial integers. So we need to have proc2 serial bytes, okay? And we give it some kind of open array of those units, okay? Let's just have it as a sequence, okay? So converts a sequence of bytes to a surreal value. And so we just do that, right? And that's it. Done. I'm not gonna support making a sequence of bytes in another way for now. We'll see. We'll do it when we need it, okay? Just to keep it simple. Okay. So next is this is supposed to do the same thing. So we're just gonna do proc, and this is gonna be the same thing. There we go. And then we have the other way around to basically extract it, which kind of makes sense. So we do proc 2 bytes. Okay, so we need to make sure that it's that, and then we can return it. And I think that's literally it. There's nothing else to do for this specific type. So yeah, good enough. And we just need to make sure that we import, include that somewhere here. Integer, and we have also, we can do in order, right? So we've got integer value, and we can do bytes value. And hopefully, when we try to run the test now, it's gonna find it. And the card identifier, surreal bytes. Really? Oh, I think I know. Because we're checking for it explicitly here, so we need to import yet another thing, which is surreal types. And this should go in front of this. To be alphabetical order. Okay. CBOR surreal types. What did I call it? Surreal types. Oh, because it's not just CBOR, it's under types. Such confusion. Import. There we go. What a mess. Types, please. I'm getting mad. Okay, the code byte string worked for this value. So now I would just need to find a way to get something longer and decode it into that. So let's try to force string into that array, okay? Because string, in theory, in nim is just literally bytes, right? So can I do something where I say, this is already making me think of encoding. But we need to do it manually. So again, we want a string of bytes. And we just need to define the value 25 again. Which was, I believe, this. That will be over 250 something. Ay, 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 ay. Yeah. Okay. So let's just do this. No. This thing. Okay. There we go. So this should be number 500, encoded as 2 bytes. Now we just need to add 500 values here. So in theory, yeah, this should be fine, right? 4, 0 to 500. Okay, from 0 to 500, we're gonna do data. Add. And let's just make it that this is a UN16. Okay. Wait, not UN16, UN8. And we're just gonna make sure that these are UN8s as well. So we're gonna add basically the I to that 500 times. Okay. So this way we're gonna have enough data. Then we can try to decode it. And we can start reading the values. So we need to make sure that it's bytes, and then for 0 to 500, we need to make sure that at that index we have that same number encoded, and that's it. Split it in, but got this. Oh yeah, so this is happening automatically depending. Oh, it needs to be inferred from here. Interesting. Oh, it's out of range of that. Okay. Oh, that's true. Huh. So I can't even store them like that. Not 500 numbers. But what we could do is to make them just a normal value. Okay, no big deal. And we're gonna do 256 mod. I think that's how it was. As UN date. Ah. Bam. Possibly, maybe it's gonna work. Um. Um. Add is unhappy because this on the right is what? Can't evaluate it or something? Let value is this, and we want value dot this. I am getting confused. Line 86. So expression is like this. String character, this, that, this, that. Oh, data is immutable. Of course. Selemi. Hmm. System fatal. Division by 0. What? Where am I dividing? Huh? Oh, mod I. Geez, the other way around. I mod 256. Oh, geez. Oh, I guess I haven't woken up yet. Okay, so that works. That means we are properly stripping those numbers off and reading them, and we're good. Okay. We're good. So let's actually commit some of the things that we did, okay? So, yeah, remove constants. We don't want that, okay? So, remove unused constants. That was just trash. Then, yeah, let's just commit those things that we added to integers. And we're gonna ignore the bytes for now, pretend they don't exist. And inside the reader, we just need to make sure that we do the endian stuff. So we have our read 2 bytes, and we got rid of the word ands, bit ands, and we do everything with the big endian here. So that's that, and we also have all this fun stuff. I wish there was a way to just select a bunch of lines and just click, hey, commit those, not something else. All right, and serial types, we haven't touched that for that particular reason, nor that. And we have the tests, where we can basically, where we can do fun stuff. What I'm gonna do in tests, I'm just gonna cut out the byte tests, while the rest is gonna stay, okay? So, bam. Fix and test integers. Decoding. Okay. And then we can put it back here. And now we can basically do, hey, we have the byte string decoding. Okay. Implement byte string string decoding. There we go. Perfect. We're moving forward. We're actually solving problems. The biggest are to come, but at least we're learning, right? So if that's the case, I'm just gonna quickly just go on and test the positive integers decoding, just so that, you know, we can finalize that. So positive integers, we're gonna start with something similar to here, okay? Where I have this specific value. So let's do const data is, and we just have this. Okay, that's our data. And the code is here. We need to make sure that it's a real integer, and value is, this will be 1, 2, 4, 8 is 9. Okay, that's the thing here. And now we're gonna copy it, and number 2 will be, let's say 24, right? So I should be able to just do 1, 1. Okay. And the next one will be something else. So I'm gonna use the fancy calculator to just get those numbers. So let's say I want number 69, okay? So for that, we just do 0, 1, 0, 0. And then we're gonna do 0, 1, 0, 1. Okay, and that should be, when we decode it, should be 69. And then we're gonna do a third one where I want a 64-bit integer. So we're gonna do straight up. So this was 1 byte, 2 bytes, 4 bytes, and this should be 8 bytes. Okay. So now I just need to write down the 8 bytes. 420, 69, 420. And we have 1, 2, 3, 4. How the hell am I going to store that number? 1, 2, 1, 2, 3, 4, 5, 6, and nearly 7. 1, 2, 3, 4, 5, 6, 7. And I can't put even more. 1, 2, 3, 4, 5, 6, 7, 8. Okay, so we've got the number here. This should be that big number. Oh no. Yeah, decimal. There we go. So I can just plop it here and just start dividing it. Right? Oof. That's 8. 8. I mean, this would be probably faster with a mouse. There we go. 1, 1, 2, 3, 4, 5, 6, 7, 8. There we go. Okay. So now I just need to make the rest of them. Was it Alt Shift? Yes. 0B. Underscore here. U8. And commas everywhere. There we go. So we should be able to basically get this value. Okay. That should be the value. A really large value, but that's what apparently we can represent with N64. Okay. And that should be that value. Okay, let's test it. Nope. So, type mismatch. This thing, it shows N64. What? U64. Okay, treat it as U64. And now it works. Okay, because it couldn't fit into normal N64. It's unsigned N64. And that worked. Okay, so that's good. So that's for the positive integer. And then we're gonna repeat with the negative ones. Okay? So for the negative integer, first of all, we actually need to say check if decoded.int is negative, is false, okay? For both of those, because we need to make sure that it's not positive. There we go. That's positive, then we've got negative integer. So we can probably copy this initial thing. And here, the thing is that instead of... Wait, what are we doing here? Why do we have 1? Okay, so if I'm gonna run this now, I'm just gonna take this out of here. Okay, I'm gonna run it now. It's gonna start failing because because I have typos. But because it's probably decoded as negative because I gave the initial value of 1, which is supposed to be negative value. Huh. And now it's gonna be failing. Yeah. Decode positive integer. Check failed. Is negative. So there we go. So we need to make that positive integer has 0 as our major type. Okay. That's gonna fix it. And now I can go to the negative where we have the 1. And this should be the same thing. We're just gonna make it, we're gonna add 2 to it. So it's gonna be 11. And it needs to be negative now. There we go. Okay. Decode byte string number 1. I mean, not really. We're just gonna do number 2. Where we are going to try something with 2 bytes, okay? So we're gonna make it a, first of all, negative. So yeah, first of all, it's negative value. And here we are suggesting, so this is 1 bit, 2-bit value, okay? And for 2-bit value, we can just say, let's clear it all. We're just gonna say that it's I know 1001. Yeah. Kind of a small number. Let's do, because this should be up to 65,000, so let's do maybe 25,000. There we go. So I can just type it normally. Put it to the side. And the value will be what do we have here? 0110. Oh, what? Insert doesn't work? Seriously? VS Code doesn't support switching insert mode? Oh dear. That is truly surprising. 0110 0001. Then we're gonna do 1010, and here we have 1000. Okay, this should be 25,000 and negative. Okay, so in theory, we could actually do additional checks. So check decoded to int 8. Okay. And this should be 69 as I8. Okay. It should be. We should be also able to do u int 16, which will be 16. Okay. I'm just running through those checks to just be able to just load a little bit more. And for that, I need the actual value. Comma surreal value. There we go. Okay. Where was I? Major, argument, all that stuff. We can just hide those for now because they're just getting in the way. Break we can get rid of. And we were checking this one. So we could similarly do something here. Where we check that this is correct, and I can actually do it in 16 and to uint 8. Do I even have uint 8? Because that doesn't make any sense. Or no, it does. Okay. U8. There we go. So this should be fine. This should be fine. And this is the 64-bit. So here I can do only to uint64. Because int64 won't fit that value. Okay, there we go. So that's that. And we're going to continue with negative numbers here. So basically, if I do 2 int 8, and I should have basically negative 8, negative 11. That should work. And yeah, I can check for other ones here. So that's good. And then we've got this one, which should be the 25,000. So we can do int32, for example, and that should check it properly. So that's good. And now let's just do one more test where we're gonna test the last possible. These are not positive, these are negative. What the heck? Number 2 and number 3. So this is where we're gonna select the 4. So we switch this to the 4 byte length of data, and we're just gonna grab something that's length of 4. So let's say we're gonna make it a value just straight up 69. Come on. What the hell's going on? I can't press number 9. What? Something's breaking. Am I writing? Oh, because I have octal. There we go. I need to select here. 69420. Okay. That's going to be the value that we're going to try to test. Okay. So to write that, we'll need 4 bytes. And we're going to go from the end. Where did my calculator go? Here. So going from backwards, 1100. Here we're gonna have 0010, 1111, 0000, and here we have 001, and everything else will be just a bunch of zeros. Okay. One extra. There we go. So this should represent value 69420. Okay. And it should be negative, so I can compare it and end 32 because other one won't work. Let's just do 64 just for fun. Value of negative 69420. And I spotted a mistake. This needs to be negative here as well. There we go. So let's run those tests and see if they all pass or I did something wrong. Failed. What the hell? Oh, I have check again. Wait, sure. Where the hell did I have screwed up check again? Run the test, please. Decode negative integer 3. So that didn't work. The rest worked. Just the last one, for some reason, didn't. And why is that? Let me just inspect the values again. Correct. Everything looks correct. What the heck? Decode it. So this should be 1 byte because it's 24. 2 bytes. 4 bytes. We have 1, 2, 3, 4. This show us where it failed. Okay, so all this worked, it's just this failed. Interesting. So I wonder if 2 int 64 we have some kind of mistake in there. And Tara says your test framework doesn't have overload for check that takes 2 arguments. Expected and actual. No. You just run the thing here. This is like a built-in simple framework. It should print difference. Possibly. Here I'm getting check failed. I know that it's not the thing. It was 0. See, so we got decoded to 6 and the N64 was 0. So we know that this returns 0 somehow. So let's investigate. 2 and 64. So that's fine. And oh, I see, because this is the weird part, because the whole thing is that the number that we're getting from CBOR, or in this case not from CBOR, from inside the surreal value, the integer here is a uint64. This is a uint64. That means it can contain values larger than just than the signed int64 can do, because this is just, you know, converted to the signed one. So here I'm basically checking what is the highest possible number of the int64 and converting it back to uint64. Then I'm checking the negative. And for the negative, it's basically -1. And I need to, you know, decrease it and then convert it to uint64 so that I can compare them as negative and positive and whatnot. If it's negative and value is larger than either the max minimum positive or maximum 64, we just, oh, I just forgot to add the return value, that's why. Oops. So return value, integer value to int64. I mean, at that point it should work, right? And if it was negative, times -1, if not, that. Okay, so that's the only thing we were missing. Good. We just missed the return value and was returning the default. Great. It works. And Taras, you're probably like, what the hell? How we were able to do without a return value? Basically, nim automatically assigns a return value to the default value. So you can, instead of that, I could just do result is this, because result is the implicit variable created by nim. How do I like TDD? Just like usual, don't enjoy it because it's tedious and boring. But I know that it, you know, it picks up problems and is a way to test the functionality as you know, to some extent as if you were using it. So that's good. Okay. We've got our byte strings and everything tested. So I'm gonna push the uh, test. What is it? Test integer conversions. There we go. Most of them are tested. Great. Yes, I'm getting much value out of that. It's just not enjoyable value. That's my problem. And already we have so much here that I will need to split this file into multiples because we're going to hundreds of lines. Because we have the basic head stuff and break stuff. Then we have decoding the integers, decoding the byte strings. And I mean, in theory, it's just 142 lines, so I might continue for a few more hundred still. Yeah, we'll see how it goes. We can split it later. Okay, so if that's the case, we can move on to the next type. Okay, because we went through byte string. Now we need to go over text string. Okay, so the way I would like it to go is that first we need to get the number of bytes, and then we get the sequence of bytes, right? And we just convert it to serial string. And that should be it. Because UTF-8 is just bytes, and I am not doing any checks if it's correct UTF-8 or not. There's absolutely no need for that. I feel like it will be just a waste of CPU power. This is going to be communicating solely and only with SurrealDB. They will be generating those. We will be generating those. There's no way of getting some invalid data anywhere. So that's it. So we've got those implemented already. So that means I just need to make to surreal string. Okay. So let's go to our surreal types and say that we have surreal string. Okay. And in our surreal value, we need to say that we, you know, of surreal string, we'll just have a string value, and that's it. So now the only thing is that we need to add the string value. Okay. Task says there is one way to check for invalid UTF-8. What's that way? You need to attempt to create a UTF string out of it. Yeah. And that's what nim will do for us. So if we're going to nim docs again, manual, we should have something on strings here. Encoding. All nim source is UTF-8. Okay. Indentation. Comments, multi-line comments. Where is that? String letters. Blah, blah, blah. They contain any 8-bit value, even embedded zeros. So it's not a UTF-8 checking because it allows for anything, but that should be it. But there was some way that we could easily just convert one to the other. Is this still down? Projects. Let's go to our nim expert. Is there a way to easily convert a sequence of byte to a string in nim? Because in theory it's just the same thing. String is actually a sequence of bytes. It just has different pointer pointing at it. Oh, we just cast it. Or if you prefer the safer approach that creates a copy of the data. Oh, this method is efficient because it doesn't create a copy of the data. It just reinterprets the existing memory. However, it is important. This conversion assumes that the byte sequence represents validity of 8 encoded text. If it doesn't, you might end up with an invalid string, and the cast operation is considered unsafe. It bypasses NIM's type system, so use it with caution. Well, that sounds fun. A safer approach will be just from bytes, but it will basically copy the data, which we don't want. Because if we're gonna pass it a... So let's just see in our decoder. In our decoder, we already get a copy of those bytes. And we'll just pass them here. Okay? So let's do it where it just casts them. And that's it. Okay? So... because it's gonna be eventually the owner of that. And therefore, we don't have to worry about it doing something else. So... in our types values, we have new file, which will be string value.nym. And we copy everything that we had in bytes and do that. So to surreal string, we'll take a sequence of integer 8 and of bytes to a string, surreal string. Okay. And kind surreal string. And instead of bytes value, we have a string value, which will be... wait, how did this say? With the word cast. Interesting. The string and the value will be just our value. There we go. Yay, that's it. This thingy here will be to surreal string again. And 2 bytes. Okay. So this is something we'll do in the other spot in a second. We want to string. So if it's surreal bytes, we're gonna try to force it to be a string, okay? Return, cast, string, this, okay? Okay, so we have this. So let's just do case of value kind. If it's surreal string, we just return the value string value. Okay. Of surreal bytes, we're gonna return this thing. Else, cannot convert non-string value to a string. I mean, in theory, we could make conversions of integers, right? And everything we could kind of convert to a string. So yeah, so we should probably do of surreal integer and just serialize it. I don't like that, but oh well. Okay. So return. How the hell are we doing that? Let's do then value dot to int 64. Okay, this should give us the integer 64. If we can't do that, it's a problem. And we're just gonna turn it into a string. And there we go. So this will be our handling of integers. We have bytes which go first, then we got strings. and we don't have anything else yet. Cannot convert a... How the hell was formatting? I keep forgetting how is formatting. Uh, Value kind or something like that. We had some kind of formatting somewhere here. Where was it? Because you do it differently in different formatting in SurrealDB, different formatting in C#, different in JavaScript, different in Unreal. Things are mixing up in my head. So let's do queries, RPC, and we should have an example over here. Okay, we can just provide a list of those. Okay. And for that, we need the string utils, I guess. Possibly. So in that case, I need to actually do it here. Import string utils. Okay. And that means we have to do... I think this is going to be good enough. Yeah. Let's try that. It will tell us if there's something wrong. So that's that, right? Great. We have our toString. So the only thing now is that we also want to be able to convert just a normal string proc to surreal string when we pass the string, and we just save the value, right? No big deal. And this, now if we give it this, it's gonna collide with something else, so we want to accept only strings. There we go. Okay, great. So in that case, in the bytes, the bytes should be actually a little bit smarter then, because that means that in bytes, we can say 2 serial bytes for this and proc 2 serial bytes with a string, and we just can just cast it to a sequence of uint 8. There we go. And 2 bytes, we should do the cast value kind. If it's integer, really, we can just do 2 bytes on something like that. I'm not doing 2 bytes on integers. Okay, it's a little bit overkill. Of surreal bytes. Okay. Then we're gonna just say do that. If it's a string, cast it to string. Otherwise, we're just gonna do the exception. Can I convert this to a sequence of bytes? And there we go. Okay, that looks a little bit nicer. Great. This is definitely not the Yagni, as the, you ain't gonna need it. But at the same time, I'm making a library so for some other people to use it. So that's my problem here. Just see roughly how much time I have left. Okay. So that's the case. We're good. Let's just save it and see what happens in our tests. Because we have our reader, we tested that, so we can just test our other decoders, right? So byte string, gonna do the same thing, exactly the same thing for the text string. Text string and text string. So here we define that we have just two characters, right? So how do I make, basically I want the string to binary, and we can use our browser for that, okay? You go up there. We don't need a common FS anymore. We can just do text to, or like UTF-8 to binary. There we go. Go away. Don't want pricing. Jeez Louise. Question exclamation mark. That's what I want. Go away. What a stupid website. Just, yeah, I want to sell you stuff. Screw you. So this should be my value here, okay? What the hell just happened? Zero, what? 0010. 0010. 0001. Oh. That's what happened. There we go. So I want to decode it. I just need to make it to be a 3 to suggest that it's a string, not just a bytes array. So it'll be surreal string. Okay. And I can just check the bytes here and here. And that's not bytes value. It will be string value. And I can just say that this is a question mark. And this is an exclamation mark. And I can also check the coded to string. Wait, was it really to string? Have string value to surreal string, and then we have to string, which kind of is silly because I should just make it like this, okay? And that's it. There we are. There we go. There we go. Is this thing. That should be the first test. The second one will be, again, we want number 3. And here we specified that we want 500 bytes. But I have a different plan. So what we're going to do is we're just going to get some text. Let's go with my favorite for testing, Terry Pratchett quotes. Okay? Quotes by Terry Pratchett. Let's go to some page number 4 or something. And let's find something longer. Okay? There was one here. Sure. Ginger, you know what the greatest tragedy is in the whole world? It's all the people who never find out what it is they really want to do or what it is they're really good at. It's all the sons who become blacksmiths because their fathers were blacksmiths. It's all the people who could really be really fantastic flute players who grow old and die without ever singing a musical instrument. So they become bad plowmen instead. It's all the people with talents who never even find out. Maybe they are never even born in a time when it's even possible to find out. It's all the people who never get to know what it is that they can really be. It's all the wasted chances. Perfect. That's a nice quote. So let's copy that and let's just say it here. Okay, so constant text is, and we just paste it here. Okay, it's gonna be a long line, but oh well. So we've got that. Let's just call it quote. Okay. So that's obviously it's a quote, and we're just gonna add dash dash Terry Pratchett, comma moving pictures. Moving pictures. There we go. So this is gonna be our quote that we're gonna encode. And how many characters is that? 726. So that should be perfect for 2 bytes. So how do we do that? We need to add it at the end, right? So let's do data add this quote. Is it gonna work? I am not sure. It's probably gonna be unhappy, but we can try to decode it. It should be surreal string. Okay. And then we need to check if decoded string value dot, I mean, if it's just a quote, right? And the same thing here. Let's see if all that works. I very doubt that this will just work. We'll probably need to do some like 2 bytes or something. Yeah, mismatch got string for int2 int64, but expected sequence. Wait, what? Which line? After return statement unreachable. What? 22. Oh, bytes value and string value. Bytes value 22. Oh, because we don't need that anymore. That's unreachable code. And additionally, in our string value, 17. So got string for 2 and 64 value, but expected a sequence. So oh. Wait, we want to get this thing. So if it's integer, we do value value would be 2 and 64. I mean, that should be surreal value, right? Unless I need to wrap it like this. Is that the case? Expect a sequence of U and 8. What the heck's going on? Oh, as a return value. And that's for string value. We want a string. Dear oh dear. Yeah. Now it makes sense. And now we just have a different error. Now in our tests, line 178, which is exactly what I thought. 2 bytes. Is there something like that? No, there's no such thing. So what we need to do here is basically cast to uint 8, and we're just casting the quote, right? And that's it. So hopefully that's gonna fix it. No, expression cannot be cast to uint 8. Expression. Oh, because this is a constant. So if we're gonna make a let, it possibly is gonna allow us to do that. Nope. What? Um, oops. What the hell's going on? What is an expression here? Quote. Is it considered to be expression? Well, let's rename it to text. Now let's see if that's gonna help it. Nope. So I guess we just can't do that. That is interesting. Oh, geez. Sequence of uint 8. Jeez, Louise. Now it should make more sense, right? Oh, now it's fine. Kind of, but kind of not. Uh, if it's this, decoded was that. Nope. Oh, I see. Ah, okay. So, I guess when we're casting, we also including the, end of string character or something? Because behind the scenes, there's a C string. Hmm. Okay. So I think this is due to us first taking this and casting it to that. But no, because this, we just added those 2 bytes. So if we're going to decode it, check the length is 2. Something tells me it's going to tell me that it's 3. Now, check the first and second value, and then decoded adds the question mark at the end, the empty value. So that means that this thingy, when we cast it to string, it adds that extra character at the end. Why is that? Why is that? I do not know. Let me just check one other thing. Because this was suggesting we can do that, or from bytes. Let's try the from bytes approach for now. Return. This will be string. So from bytes, and we give it the value, bytes value. Okay. But at the same time, why would that happen? We had a string, so it should be a string value. So, oh, when we create it, we do that thing. I see. So in here, we would need to basically have the same situation. String dot from bytes. And let's try to run with that and see if we're gonna get anything else. From bytes. Not existing. So let's search if we have that somewhere in here. Not the manual. Let's just search for from bytes. String it is from binary. Oh, that's a new one. from bytes. Parse, SQL, nim script, all that fun stuff. We don't have such thing. Let's go to standard library and just see if we have something in maybe string utilities or something. String handling. So utilities for C string handling. I don't want to deal with C string, to be honest. Data strings for concatenation, adding new character, and in. All characters. A set with, oh, okay, so these are just constants. We don't care about those. For formatting, abbreviation, add F, add separator. Contains, continues with. Returns true if S continues with substring at position this. Okay. And then delete ends with escape find format, blah, blah, blah. Bunch of formatting. Int to string. That's interesting. Blah, blah, blah. Bunch of parsing. So parse biggest end, big end, boolean, enum, float, integer, remove prefix. So none of those. Splitting to binary, no. So this is from string to something else, which is not that much fun. Then we've got iterators. We don't care about iterators. It's one thing that we want to avoid, and that's it. Oh no. Let me ask on Discord, because I'm getting confused. So let me just make it larger a little bit, and there a way to efficiently convert a bytes sequence to a string? Because it should be. I tried casting, but it somehow adds a third character. Or does it? Because let me just check my check and see what the hell's going on. So in the decoder, no, in the tests. Inside the tests, I checked if the decoded string value length is 2, and it said yes. Okay? It straight up said yes. And it is a surreal string. And therefore, length is 2, only those 2 characters. But when I print it, it just adds a third one. So, what the hell? True. And true. True. False. So let's just see the decoded. So decoded for the string value. And Ox Trooper, thank you for following. You just got us to 40 followers. Sure, I can follow you back. Alrighty. How are you doing, by the way? What brings you here? Okay, so we tried this one, right? On a serial value, and we found that if it's a string, we just return our string value. We just return the damn string. So how is it that when we run the test, we're getting weird stuff? Oh, and now we have, of course, from bytes, which doesn't exist. So we get rid of that part, and we get rid of that part. We bring it back to normal, right? So we can see that everything goes fine. The code byte string, and then we get to this one. So this failed. This straight up failed. The code was this thing. Where did that third character come from? Can I actually... where is it? Where is my thingy? False. It evaluates to this thing. Buckstripper says that he's good. How are you? I'm doing well. Enjoying some NIM programming. That's always fun. Unless you're dealing with something like that and you have absolutely no idea how that happens. Because if string length is 2, it doesn't count a third character or something. So that means that when evaluating the length, it doesn't count the character, but when printing it, it somehow prints it. So character. Okay, and this would be character this. Coded will be casts. How do we do the cast? Because this is the decode. So text string, we just get this. We read the bytes, and we pass it to serial string. So we do to serial string, and we just do that. Okay, so we're just gonna pass it like this. Okay. True. Blah blah blah. So yeah, I'm gonna just copy that code and ask it on Discord, because I have no clue what the hell's going on. So basically, is there a way to efficiently convert byte sequence to a string? I tried casting, but somehow adds a third character at the end of the string that isn't even counted in the length, but shows up in comparisons. And we should be able to just provide this code for someone to figure out that, hey, we have a test, we give it data, right? And we do decode, which basically casts this way. Does this. And we can just say, string val is this, right? And then we're just gonna do check. It's length 2, we check for 2 characters, and this is false. It evaluates to this thing. So all I can do right now is just ask about it and move on in the meantime, okay? So we went through this one. We, in theory, have the other comparison ready as well. So that's good. We don't need, I mean, we don't need that length check, right? Well, let's have the length check just in case. And that should be it. So the next thing is something else, which is arrays. And this is where it starts to be more interesting, because this is where we will be having nested values or whatnot. So let's go to our type. Where is it? Surreal type. So we will have surreal array, okay? And that array can hold some additional values. So our surreal array, we can implement it in our surreal value. So of surreal array, we have literally a sequence of other surreal values, because an array can hold whatever goes. Just whatever goes. So in that case, we'll just need to have the array value, and that's it. Because sequence already allows us to check the length and whatnot, and I don't think we need to hold any other context. So for the array value, how on earth would we do that? So before we start implementing that, let's just look at our decoder for the array. So for the array, we basically need to, this is no longer number of bytes, it's just number of elements of the array. Okay? And here, we should actually allow for getting not just the full argument as a number, we should also allow to check if it's indefinite length. Okay? But for now, I'm just gonna do handle indefinite length arrays. Okay? That will be separate. I'm just gonna add it here. Okay? So number of elements, we have that. And then basically for each element, we'll need to handle the value. So we'll have our elements here. Okay? And for each element, we just add it by decoding further inside. We decode element, whatever it was, and we just push it into elements. And then we go and we go and we go. And after we're finished, we just return elements to serial array. There we go. That kind of makes sense. Okay. So that means we can make a new file, array value.nym, and we'll have our proc to serial array, and we just give it a serial value, sequence of serial values, and that's it. So that's it. The same thing goes here. It just does it automatically whenever we give it the sequence of serial values. And then we have to array, so we just do that part. Right. And not to array, to sequence. Okay, there we go. That's a little bit more of NIM language. Great. Okay, that makes sense. So inside here, And the decoder, I guess this will be it. Wow, this is like really, really, I mean, really simple. So I guess I should first check, because we could support the indefinite length arrays here straight on. Because let's just go to the spec to quickly see it. Warning, bright light. Here. So type 4 is an array of data items. So the argument is the number of data items in an array. Okay. And the thing is that we need to also support the indefinite length, which is here. The indefinite length array and maps. Indefinite length arrays and maps are represented using their major type with the additional information value of 31, followed by an arbitrary length sequence of 0 or more items for an array or key value pair for a map, followed by the break stop code. In other words, indefinite length arrays and maps look identical to other arrays and maps except for being with the additional information value of 31 and ending with the break stop code. So that's that. We just need to check if it is something, of value. So the thing is that we have the head major and head argument. Okay. We have that. So we could basically add a simple thing. Let is indefinite. It'll be reader dot is indefinite, and we just argument, I believe, head argument. That's what we're giving it. Okay, head argument. And then if is indefinite, we're gonna do something. Otherwise, we're gonna do this part. Not indefinite. Argument is number of elements, okay? But when it's indefinite, we'll just have while loop rather than for loop. Okay? So let's just quickly implement that is indefinite. So we need to go to reader. Okay? So we had the reading all those values is break, that's one, and then do proc is indefinite. Okay, and we don't need a tuple. All we need to do, all we need to have is the head argument, or just argument. Okay, there we go. And basically, check if arguments suggest an indefinite sequence. So there we go. That's all we're doing, comparing if it's 31. Not much else. And we don't even need to pass a reader here in the first place. Yeah. It's that much fun. And therefore, we don't need a reader here as well for is break. Because why do we need to pass the value? The only thing we care about is the tuple of head and argument. Okay, so that means that in our test of break, we should just do head is break. Okay, that's that. Same thing here. Head is break. There we go. So that got a little bit simplified. So now in our reader that we have the is indefinite check, and decoder we can just say, okay, if it's indefinite, that means that we need to basically do a while loop. Okay. So what we're gonna do here, while true. Okay, and we're gonna break it manually. So here we just read the head of another item. Okay. And if it's break, then we break. out of the loop, and we just completed our array. Okay. Uh, so we actually need to probably have elements here. Okay. Elements is a sequence of those things. While we go, when we break up the loop, we just do the similar thing here. We just return that. Okay. So that part is fine. And that suggests that we could kind of create those elements up here and return them at the end. So if it's indefinite, do this. Otherwise, we do the not indefinite here. Okay, so unknown number of elements. Here will be known number of elements, okay? So we just keep adding to those, and after we finish all of them, we just return them. There we go. Great, that sounds good. So now here's the difference than something else. Because here we're already reading the head, just so that we can evaluate if we need to break first. If it's a break, if it's not a break, then we want to elements add and the code, which means that we want the reader, but we're also gonna give it the head. Okay, so we're gonna have a variant of this decode that next to the reader, it also brings the already existing head. So let's do it. Let's say that we have the head, which is the tuple of this and that. Okay. And that's it. Okay. So here we can just say that those are basically the head. There we go. And we can continue on. While we're gonna define an additional one, which will be proc decode. We give it the just a reader, and what we're doing here is let head is this, and we just call this thing. So what that means is that we can just call the code by giving it a reader, and it's gonna automatically take the first element and continue. But for elements like here, an indefinite, we can just get that head manually, check what we have to, and only if we know that there's an element, only then we are going to actually, do something with it. Okay, that makes sense. So we're gonna add that element, and then after the element, we're checking again. Do we have break? No, that means that we have another element and we take it. And we can reuse the provided head because the reader already advanced one step forward. So, wow, that was actually really easy to implement. Okay, programming is fun at sometimes. At times, programming is actually fun. So I'm gonna go for another little short bathroom break and be right back with you. All right? Alrighty, I'm back. And looks like we've got an answer. Multiple answers to our question. Wow. Nim Discord is absolutely amazing. So, and let's says wrapping curly for async. That's not what we want to do here. Okay, are you doing anything else in the code? Okay. And someone else said it should be cast pointer string value address, by the way. And if you want 0 copy, move it, or maybe cursor, but I haven't tested. Right, you could make a proxy object that dispatches requests into, okay. So we're gonna try this, and we're gonna also answer, okay. The code doesn't do much really. And we're gonna provide it. Okay, so first of all, I want to try it with our string value. There we go. Instead of doing this, I'm gonna try that. Cast a pointer string to value address. But that will be a pointer string. What? That's not gonna be a string. That doesn't make any sense. So let's do this. So we've got this and to surreal string. Okay, and let's have the true surreal string as well. And that's it. And the bytes from in the decoder aren't used anywhere else. And it's a copy. So you see whole sequence, not a view or anything. So the string can own it or something. Own it. Not sure if it's a correct term here. So we're gonna give the answer, and I don't know. We're learning them. That's the goal here. So there's a chance we're gonna learn something. So in the decoder, and the nice thing about it is that we just got decoding arrays into decoding arrays, which is absolutely awesome. So hopefully all the other tests will be fine. So now we need to figure out how to actually start encoding those values. We're gonna do it manually still, okay? With comments, we should be fine because I feel like those tests should be minimal, but still have the nice values about them or whatnot. So let's go to our tests wherever they went, because we have two sequence, all that stuff, so that should be fine. And I'm not gonna go into serializing the string yet, because that's kind of pushing it a little bit. So where do we have our tests? There we go. Reader, we can just hide all those. And our strings for now. So, come on. So with our strings, we're gonna have an array, sorry, test decode array number 1. Okay, I'm gonna start with our data. So our it doesn't add the terminator where you cast it. Yeah, there should be no terminator as far as I know, as I'm just reading raw bytes that don't have, that won't ever have a terminator. Well, that's the thing. So with the decode array, what type was it exactly? Array is number 4. Okay, so let's just copy something from here. And we should be good to go, okay? So this is 1, 2, 4. So 1, 0, 0. Okay, so that signifies an array. And then we can signify that we have, what, 2 elements, right? So in here, array of 2 elements, okay? So now we need to provide 2 elements. And so finite array, okay? So in that case, we can just say that, hey, we're gonna encode a simple integer of value 1, okay? Positive integer 1. And then the second one will be negative integer. Let's make it maybe something like this. Or maybe actually make it a bit longer. We're gonna make it 24, so it'll be 11000, right? Because 16 plus 8 is 24. Integer by 1 byte. And 0b. And we need to encode some kind of value. So let's do 1111, 1111. Okay, that's on a break. This will be the integer 255. So this is not positive, this is negative. So be what, negative 156 in that case? I might have wrong encoding here. Oh, okay. I might have weird numbers here. Because negative values wait a moment, are my integers wrong? First, let's just check Discord. Have some type, I don't know, curly dispatcher. This is not it. So we didn't get an answers yet. So I just want to see the numbers because I'm getting confused. So unsigned integer of the range from 0 to this thing. And this is from this to negative 1. The value of the item is negative 1, is minus 1, the argument. For example, the integer minus 500 will be this. So this is basically 499 and decimal minus 1. Oh, so this is something we totally missed. That means we need to completely change how we are converting those values. Oh, wow. Ay, ay, ay. So negative, this will be negative 256, not 255. Okay, so we're gonna add this here as a test because we need to have that. Okay, and this should be enough. We have two values, 1 and 2, and due to nesting, they should kind of figure it out. Okay, so in that case, decoded will be decoded data. Kind needs to be array. There need to be two values. First one will be serial integer, and it will be 1. Okay, and is negative false. Then another one will be serial integer, is negative, will be true, and value will be 255. That's the thing, but how do we do that? Do we operate, when we decode things, the negative value is a little bit larger than what we can store inside the thing. So we will probably store it this way. And then when converted to actual numbers, we'll need to take care of that. Oh dear. Um, Surreal value stores negative integers as value minus 1. Okay. There we go. So we're going to store it that way. Okay. And that should be it. So I want to do decoded array 1 to int 8, and that should be negative 256. I think that's within the range. Okay, I think. So yeah. Oh no, that would be 125. So I need to do int 16. There we go. To actually get to the value. All right. Makes sense. Should be really negative 256. There we go. So this is our test, and that's how it should work. So let's try to run this test and see how it fails. Okay, number is out of range. 256 for sorry, 16. We already figured that out. And reader. Reader line 51. Oh, yeah, of course. Head major and decoder. So our decoder needs to also know not only serial value, but serial types. Okay. Head major. What? Oh, wait. Not just that. So serial types, that's not it. This is reader, and this is inside CBOR types. There we go. I hope I can just run them. as a comma. So type mismatch is indefinite. Reader an argument. What? Coder 32. Oh. Head argument dot is indefinite. That's how we do it. Okay. And now decoder reader CBOR line 44. Code reader. Expected this and that. Oh, that is right. Wasn't there like forward declaration or something? Because the thing is that we want to use the other one from within it. That will be one option. Because we have this one here. And this one calls this one. So it's after that. But this one also wants to call this one. So to avoid that, we're just gonna say this. Okay? And we're just gonna pass the head. And that should be good enough. Okay? Should be good enough. Okay. So yeah. And we'll just need to continue with the thing here. Here we have not indefinite. Wait, if it's indefinite, do this. Not. Oh, we don't need this copy of data here, right? Yeah, because this was just straight up a copy. There we go. So we got that part, and we don't nest it anywhere else yet. Okay, sure. So we're gonna run the test, and what's gonna happen now? Okay, we've got failures and stuff. So this failure is expected, and then this thing is expected as well. And then the array. What happened? Okay, it was negative 255 while we expected negative 256. Perfect. And that's it. So we're good. So we just need to fix our integers. So let's actually go and add the tests for those positive integers. Positive integers should be just like that. While negative integers, wait, this is the coder. Where's our tests? Okay. So the code positive integers, that stays the same. But for negative integers, I want to grab one more because I want to ensure that integer 0. Okay, I'm gonna start from 0. So I want to decode the value of 0, 0, 0, 0. And the thing is that it's negative. Internal value should be 0. But when we convert it, it should be negative 1. Okay? That's the whole idea here. And then here should be 11, while really should be 10. For here, it should be 24999. Wait, actually the other way around. 25001. This should be negative 12 and negative 1. There we go. So that and negative number 3 will just add additional 1. There we go. Okay. That makes sense then. That's how it's supposed to work. And yeah. Okay. There we go. So now all those tests will start failing. I have way more fails. Okay. So we have the negative integers that are all failing because they're wrong. So now we can actually go on and fix our integer value. Okay. So to surreal negative integer, all that is actually should be changed here. Okay. Because when we take the value that's supposed to be negative, okay, we need to actually increase it by a little bit to surreal negative value, and we give it a positive one. But still, it should basically be -1. That's how we're storing it. Enter to a negative surreal value. This will modify the value by removing 1 from it. Okay? Because that's how we're storing it. That's the only reason. We're just storing it by having it a little bit smaller. And that's it. So then, to surreal integer. This is again where we're storing it. If it's negative, this -1. Okay? There we go. And then the other way around, we need to do things a bit differently. Okay? If we want to int 8. Oh, that's actually gonna simplify our stuff here. Huh. So to int 8. If it's not a surreal integer, then it's unhappy. If it's negative, it's unhappy. So all those, they won't even tackle negative values. Then we got the to int 8. And that means that our positive and negative values are a little bit different now. Ay, 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 ay. But that also means that if it fits within the max int 8 here, we don't need to hold that value at all. Okay, great. So basically, if, or does it? Oh no. So an example here would be where we have is negative, right? We store that value, and the next value is 255 because we're storing it as that, right? We wanted to assign value negative 256, and therefore it's stored as 255. Therefore, when we're checking if it's gonna, or let's say negative 127, that's what we have in here. We need to basically check if both high and low values as the positive number are within the range, it's gonna work. Otherwise, it's not. Okay, so we're good. That's great. Awesome. So we don't need this thing. We just do that part. And if the is larger than max int 8, okay, no matter which direction, it's not gonna fit. Otherwise, if its value is negative. Yeah. So this is where, instead of doing that, we're gonna just go for two separate values. If value is negative, then we're gonna say this thing times -1, okay? And then -1 to just decrease it even more? What the heck? Yeah, to decrease it even more. Ay, ay, ay. That's fun. And why do we have it like this? What the heck? I will just wrap it in this particular order, okay? Because this should be already a negative number, and we just decrease it even more and convert it to int 8. And that should be good enough. I know that it's not the most optimized way, but it's something. And here we just do that. We don't need any additional wrappers. Okay, I am liking that approach. So the same thing will happen here with int16. We don't need any fancy stuff. There we go. And for return, we just need to do if value is negative. We'll just do that. Okay. So let's see if some of them actually started working. I don't think so, but maybe. The code positive integers started failing. Oh no. Failed. Check failed. The code to int 8. We got 69. We got return -69. Oh no. So oh, of course. We just need to do this. Because it just fits. So for positive, yeah, it's gonna be a little bit easier. What just happened? So our positive integers work. Our negative ones still don't work. I guess not everything works yet, right? So let's just continue with this one. We know that we don't need this one. Okay. So we can just say like that. And here, if it's negative, do this. Otherwise, do that. And we're gonna leave the int 64 as the last one because, yeah. Please, some negative, please work now. Code 0. The coded initial val. This to int 8 got -12, or we were expecting -11. I mean, we're expecting -12. We got -11. Okay, this is interesting. So looks like we might be actually failing at something. Oh, yeah. So we are calling probably internally to serial negative, and this is already decreasing it, right? And that's the problem. So let's take a peek at our decode. Our decoder, when it sees this thing, it takes the argument, right? And passes it here. But this argument, we should already increase it by 1. So we're gonna do to surreal integer, and we're gonna have value +1. And that's gonna be interesting if we're gonna get a maximum value. What? Oh. Hmm. Let's call it raw. We're gonna have a variant of it that suggests that we can specify raw. Proc. Okay. And we always give it uint64, and that's it. So converse into this will not modify the value as it assumes the value is already adjusted by 1 to be compatible with the CBOR format. Okay. And what it does is does exactly the same thing. It just doesn't modify this thing. Okay. And this will allow our decoder to just handle that, while everyone else can use this to just store the values the way they expect it. So that's good. Okay. Makes sense. And that means some of our tests should work already. So the negative integers work. Just the last one was which we need to figure out now, which will be for the 64-bit one. Okay. And then we've got, of course, our strings, for which do we have an answer yet or not? If you first do string set length, do count 0. Before you do the cast, you should not have the weird characters at the end. It's kind of weird if it still happened after this. Might be undefined behavior, but I never had issue with this method. The mystery. You can do set length after 2ig. Okay, so the thing is that that same person was suggesting to do cast pointers. So how the hell do I specify the string set length before I do the cast? How do I do the... What? That means I need to define a string first. I was hoping to avoid any copying by doing the cast. Not sure what you're suggesting with the string set length, as it implies creating a new string and allocating data to it first. So we would have let string is this, and we then whatever let text is this, then text dot set length to be my sequence length -1. Um, well, thing is that, yeah. So let's look at the test again. So in our test, where is it? Bum, bum, bum. Here. In our test for the string, our sequence is already 2 bytes long. So, what the hell? But my sequence is already only 2 byte long. There's no terminator character in the sequence. Unless... that's interesting. I wonder if that doesn't make sense, because what the heck? Let's try to do that, okay? Let's try to just test that, because this is very weird. So what the person is suggesting, because when we get the data and we call the code, it's gonna grab only those 2 bytes, right? And return them as a buffer. But then here we're calling to actually extract it. So for the text string, we get the bytes, which is just 2 bytes at this point. So let's do... Can I just do echo bytes that many? I guess I could. So let's just make sure that can I do assert number of bytes is exactly the same thing as here, right? Because that's what matters here. This should be 2, and we should get 2 bytes. And then we call the toSurrealString. And therefore, I'm going to run that first, because I want to make sure that there's no weird stuff. And where do I have an error? In our decoder, line 27. Assert type mismatch. uint64 and int64. Oh, dot uint64. Okay, just like that. Okay, so no problem. That worked. Okay. Check file, the code string value is text. Yeah, so it is the same length. Okay, we don't need to worry about that. So I wonder if in our toSurrealString, when we cast it, I wonder if that cast somehow forces string to grab extra character after our buffer. So let's do the weird stuff. Let text, okay, is any string, okay, and text dot set length to basically the value dot length -1, okay, and then we're gonna do the cast, which in theory is gonna override it. So I am truly confused. Text is this. What the heck? It does not make any sense, but let's run it. We're getting straight up errors. One is string, one is int, and first mismatch at position 1. What? And set length. New length is natural. Expression text is immutable. Oh, of course. So it worked, but the thing is that... Oh, the code was question mark, exclamation mark. Well, here we're doing the other way around. This worked. This just removed the extra character at the end. What the heck? But this failed as well. So we were checking. The code string file was... We've got that. Moving pictures. But they don't compare properly to each other. Why is that? And why is it the other way around? So in my test, I know that I must have a typo here. Yeah, it was supposed to be question mark, exclamation mark. So let's just make sure. Will that test fail or what? The first decode string worked. Okay, so that's news. That's good news. That worked here, but it failed to compare to the other one somehow. So how doesn't that compare now? Because we have got the actual text that we converted into the byte string, byte sequence or whatever. But I guess that's the problem here. It wasn't properly done, right? So let's do for C in text. Okay, we're just gonna do that and see if that makes any difference. Nope. What's the difference? Check file decoded equals text. And it's one big no. Okay, strings are always difficult, so I'm not sure about that right now. So I'm gonna think of that after the stream, okay? Now I'm simply gonna finish fixing the integer values, and we're just gonna finish for now, okay? So we were working on the integer values, right? To int. We got 16, 32, right? We simplified it. And now we have just the last one, which is int 64. We don't need those weird checks. We just check if it's larger than max. Okay. And okay, it doesn't fit int 64, and therefore when we're actually serializing it, we just do the same as everywhere else. Okay, and we just need to add a to-do, add support for larger integers. We need an equivalent of negative uint 64, because that's the value that we can represent in CBOR, but we can't represent it like natively in NIM. So we possibly could use big int and just have, you know, like 2 big int or something, but at this very moment I'm not sure how how nim is actually handling those values. So we're not gonna touch it, but when we run our tests, we should have more of them passing. As in, all the positive and negative integers now work, which is awesome. String number 1 works, number 2 doesn't work for some reason, so that's interesting. And finite array works. Okay, so our finite array works, so let's just add one more test for the infinite array, where we use breakpoints to do things, and maybe we're gonna actually nest array as well, because that will be fun to test, because our thing should already support it. So we're just gonna do test the code indefinite array. Okay. So let's define our data first, okay? So of question mark elements. So that means we just need to do a bunch of ones. And this means that this is an array of, we don't know how many elements, okay? So we're gonna start with maybe positive integer 3, right? Just like before. And then we're gonna add an additional, here we had basically negative integer represented by 1 byte. So we're gonna continue the same thing, right? It should work. And then we're gonna add one more integer, because why not? We're just gonna make it to be 1, 2, 4. Okay, it's gonna make it 4. And then we need to basically finish with just a bunch of ones. So this is the break. And for that, I want to actually define the break inside our where? That's a good point. Because we've got the code, so I think we might actually need to define some kind of constant or something. Yeah, let's do that. Let's do CBOR new file constants.nym, and we'll just specify it as const. This will be CBOR break. Okay, and that's just this value. And we're gonna add it to our decoder to also import the constants. And Hexadagos mains is asking, is 4K 240 hertz monitor, is it needed for programming? No, for programming you can just get 1080 60 hertz and you can do pretty much any kind of programming. I'm driving a 2K monitors, which are 166 hertz, but I'm running them at, no, they're 144 hertz. I'm running them 120 because I don't need more. And it's just nicer resolution if you want. Eventually I want to upgrade to 4K so that I can have kind of, when I need, I can have more of a smaller text somewhere. But it's not really necessary. Absolutely not. Overkill. I have 144 hertz because that was a good deal at some point. And that's it. And I do some gaming, so that's pleasant. And I like smooth scrolling, right? Okay. So what the hell we're doing? Oh, defining in the decoder that we need constants. Constants. Okay. And therefore we'll need it here as well. So our tabs, CBOR will have also constants. And our decoder, how are we checking for the break? We were calling is break. So we don't need that here, actually. Okay, at least for now. On our tests, we'll be able to just specify that this thing here is CBOR break. Okay, there we go. Great. The only thing is I made it with capital letters, which is kind of weird, but I think it's okay for constant. Don't remember the proper naming convention for constants. I'll leave it like that for now. Or maybe let's take a peek. Sure. Manual. And do we have constants or something? Constants and constant expressions. So constants everywhere just are normal characters. So let's maybe rename it to something like CBOR break. Okay. And this way won't show up in that funny color. There we go. CBOR break. There we go. We're good. So what's next? We've got that, and that should finish our array. Okay. Even though I'm gonna specify that there's something after it. If there's something after it, after we get out of the first one, we'll need to basically make an error at some point, but we'll handle it later. For now, I just want to test if this is actually gonna work. And we're gonna get 3 values. So we just decode it, and we have a bunch of those tests that we can basically copy paste to some extent. So we decode it. We need to make sure it's an array, and it should be 1, 2, and 3. Okay, there should be 3 elements here. First one is integer, should be value 3. Then we've got a -1, which we left, and then we also got this thing should be integer, not negative, and number 4, and that's it. So let's run this test and see if it fails or not. Indefinite array. Okay, great. So let's also do the nested indefinite array, okay? So the code nested indefinite array. So we're gonna start with an array of, we don't know how many elements. We're gonna start with the same number, but instead of this one, we're just gonna say, you know what? We have another array of, we don't know how many elements, and I'm just gonna put 3 numbers in there. And then we're gonna do CBOR break. So we should have an array of 1, 2, 3 elements. Okay? We should have 3 elements. And I'm just gonna copy this stuff just like I did before. Okay? Got 3 elements. First one is integer, and it's 3. Okay? Perfect. The second one needs to be surreal array. Okay, and that means that it should have 3 elements as well. And therefore we can just say that this will be integer 3, 3, and 3. There we go. And after that, the last element should be 4. Whew! Thanks, AI. I didn't want to do a lot of copy paste, and this should be passing, right? There we go. The code nested indefinite array. So we can just straight up nest arrays of we don't know how long, and it's just gonna work. So wow, this implement those arrays was actually really easy. So yeah, I'm happy about that. We'll need to figure out the strings. I don't know if there was anything else here. I don't think so. So I'll need to tinker more with those strings and figure out what the heck is going on there. Maybe gonna find some articles. We'll see, but for now, I know that we'll continue working on a library next Friday on the usual time. So yeah, let's push those changes as the final action. So, define constant for CBOR for a break. What is it? Head? Break byte? Okay. And then we have a bunch of stuff. So, yeah, and the decoder, the thing is that we fix the integer values. So we need to have that as a separate thing, okay? And anything else here? Nothing really happened here. Okay, that's good. So then in our surreal types or something, surreal value. Nope. Integer value. That's where we added all those changes. So we stage that file. And in tests, we can fix our things here. We'll get to those in a second. What we need to do is stage the integer changes. Integer, 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 and other is strings and stuff. So fix invalid negative integer decoding. Okay. And then we basically will do everything. This and the reader and all that stuff. So this will be support string. Whatever. Text stream. And erase. Finite and indefinite. Whatever. Finite and indefinite. There we go. So that will be it. And push. All the code is, as always, on GitHub. So thank you for watching. If you like the content, consider liking and subscribing on YouTube or following on Twitch. And you can also join my Discord. The link is in the description or sliding somewhere here on the bar below me. And that's it. I'll see you on Monday. We'll be continuing working on our game of Unreal Engine and doing C++ stuff with inventory. So again, thank you for watching and have a great weekend, everyone.